Um, Thank you so much once again, everyone, for coming all along to this venue to attend the international conference. So as we transition into the heart of SDCAT 2023, I invite everyone to join us in the upcoming keynote speaker session, a journey into the profound insights and visionary perspective that will shape the discourse of sustainable development and climate change in transportation. Please stay tuned as we commence the enlightening session from now until 11:45. Now please come to the stage. Professor Dr. Nguyễn Văn Hùng, Dr. Nguyễn Thạc Quang, and two secretary. Just a little reminder before we commencing to the keynote speaker presentation, because the international conference will use English as primary language, we already prepared on the headset for Vietnamese translation on the VIP. So please use the headset for translation. Thank you so much.
Okay, the first keynote, please, Professor Dosho, which established flexible concrete way recycling circle improve the performance concrete using low quality recycling advanced. Please go to speaker.
Xin chào. Xin chào. I'm Yasuhiro Dosho from Japan, Nagoya. I'm a major university. This theme title is Sustainable Concrete Waste Recycling System Improves the Performance of Concrete using a low quality recycled aggregate. Introduction. This study to improve the performance of concrete using a low-quality recycled aggregate. For recycled coarse aggregate, class L, low class, and recycled coarse aggregate class M. For comparison, concrete was produced using aggregate replacement method. And the study examined the effect of the replacement ratio and focus on the use of general materials. For this study on the effect of barriers, cement and coarse aggregate, that are ordinary Portland cement, Portland fly ash cement, B, type B, and Portland blast furnace slag cement, type B, and X cement. And normal coarse aggregate as hard sandstone, crushed stone, and limestone crushed stone were used. In this mix on concrete performance in addition to adjusting the replacement ratio of concrete recycled aggregate concrete. This is in Japan. 83 million tons of construction waste is produced each year. This total concrete waste account for 37 million tons. The rate of recycling concrete waste has reached 99%, but most of it is used for roadbed gravel and backfiring materials. This shows how we evaluate the application of recycled aggregate concrete. As you can see, to encourage usage, we needed to ensure a good balance between safety and quality, and environmental risk reduction, and cost effectiveness. But the environmental risk reduction is very important. This is what recycled aggregate looks like. As shown, concrete waste considered original waste consists of original aggregate and original mortar. Chloride and toxic substance such as hexavalent chromium are present in concrete waste since they are ordinarily contained in cement. In order to avoid soil contamination with roadbed, we need to develop other used appear from roadbed gravel or backfiring materials. The most promising alternatives are recycled aggregate and recycled aggregate concrete. This relationship, manufacturing energy and quality, this is high. This is high cost, low is low cost. For roadbed gravel, for structured concrete aggregate is important. Examination is the relationship between the water absorption and time of grinding treatment. This is 1, 2, same increase, decrease there, but water absorption. Yes, it is high quality. In this simulated, this is improved the eccentric trapping type for mechanical scrubbing and heating and rubbing were selected as aggregate refinement method used for building with actual roll records. This figure shows a manufacturing test on the actual recycled aggregate that we carried out using aggregate replacement method. In this Japanese standard revision in 2018, this Japanese industrial standard A5022 reason for expanding the scope of application in the reverse standard, changing of standard type. Next, aggregate. This is this A5022 in changing. Now is revisions aggregate replacement method using. The volume mixing ratio of recycled coarse aggregate class L is limited to 50%, and fine aggregate is 30% maximum. Recycled aggregate consists of original aggregate and original mortar. Recycled aggregate that used the aggregate refinement method is manufacturing in order to attain a quality variant for normal aggregate such as gravel and sand for which it is substituted. However, in order to manufacturing such recycled aggregate while removing the original mortar and advanced processing technique using special facilities is needed. In Japan, there are four main aggregate refinement methods, and these can quality recycled aggregate to safety satisfy the specified requirements. The best of these four methods using heating and rubbing 2 years, about 35. High quality recycled coarse aggregate and about 21 recycled fine aggregate from the entire concrete waste. The remaining 44 is fine powder containing a large amount of the original mortar. Also, several recycling applications that convert fine powder to widespread use is still difficult because there are problems with quality control, such as preparations at cement plants and the cost effectiveness. Therefore, the more advanced processing technique and facilities are needed to reuse this fine powder for materials other than concrete. But the cost and environmental risk may be higher. For this reason, the aggregate replacement method, which does not remove the original mortar, is effective. This is cost studies. This is aggregate replacement method. Refinement method is high cost and high CO2 emission. But recycling replacement method is low cost and low CO2 emissions. Very good simulation. This is an examination used in materials on cement N and fresh cement B, type B, and plus furnace cement and eco cement. And recycled aggregate for original concrete. For normal fine aggregate, reverse sand were used, while energy 2225 NG and LG were used as normal coarse aggregate. The study employed the recycled aggregate class L and M. And a water reducer was used chemical admixture. The quality of the recycled aggregate was 6.142 to 6.248 water absorption, low quality. And RMG is 3.60 point, middle age quality. The mixed proportion. The total 41 samples. The concrete were prepared using 4 types of cement. 2 types of the normal coarse aggregate. Oh, sorry, 2 types. And 2 types recycled aggregate, and L and M. Okay. So it's the slump and air contents was, target air content was 4.5 plus minus 1.5. Admixture at the 0.05% to 0.1%. And unit water concrete contents of FEB and BB were carried for N by minus 5% and minus 4%. This is a method, an item and method, item and method. Test item and test method. Fresh concrete and hardened properties. This is the fresh concrete with the slump was target value, lower unit was cement. Otherwise, the target value was satisfied. And colloidal ion contents and just target value of this A 5308 over 0.3 kilogram per cubic meter or less. The complex strengths. This is cement type influence the trend of strength development in which FB and BB display greater long-term strength development in relation to N, while E was nearly equal, which is a general trend. And static models of elasticity juice. This is using limestone crushed stone in the mix with RLG can effectively improving the static model elasticity. This is a relationship between a complex strength at 4 weeks and static modulus of elasticity. Figure shows the relationship. It is so. Both of the which were calculated from the density estimated from the replacement ratio, which is experimentally larger compared with the values estimated from the recycled aggregate concrete guideline equations. However, these values generally fall within the range of plus minus 20%. Drying shell change. Mixed LG limestone, crushed stone, the maximum value was 6 low rate. Even to that replacement ratio of 50%. Generally, concrete used limestone crushed stone is reported to have lower drying shrinkage, which may be casted effect. And accelerated carbonation. Figure that accelerated carbonation depth is the most affected by the water-cement ratio within the little progress in concrete with the water cement rate of the 40%. And accelerate rate is figure shows that the high correlation is obtained between FV and N. This result indicated that the target quality can be met by increasing compressive strength to reduce carbonation. This is the present slide. This is shows factor, durability factor was under 85%. That was not special on some 300 cycle of relative dynamic modulus of elasticity. The 0.5 error as mixed fresh concrete was within the target of 4.4% to 6% for concrete subjected to several freezing and thawing. And conclusions, to improve the performance of concrete using RLG. This study investigated the effect of the type of cement and normal coarse aggregate in mix, including the adjustment of the replacement ratio of the performance of the concrete. The result indicated that the performance of the concrete with RLG can be improved by adjusting the replacement ratio and selecting the type of cement and normal coarse aggregate for using addition to general considerations about the mixed proportions such as the quality of water per unit volume of concrete or the water cement ratio. This is finished. Thank you very much.
Thank you so much for your kind presentation. Now let's the time we had your more questions. Please give him a question. This topic very interesting. This is I want a question.
Okay.
I very impressed. You can measure in the CO2 emission, right?
Yeah.
How you can measure this? Very important for environment nowadays. Thank you so much for you.
This is a very low cost, good question. This is a good question. Manufacturing method mostly is easy and easy processing. This is heat and rubbing is heat and rubbing, very high cost and CO2 cost, but easy crushing only. That is low CO2 emission, I say.
Do you have more questions from Professor Dosho?
Hello, Professor Dosho. I'd like to ask the questions. I talk in Vietnamese first and then translate it to English for you, right? Thưa hội trường, là giáo sư Dosho thì là một chuyên gia về sử dụng các cái phế phẩm của nhà máy nhiệt điện và nhà máy điện để mà sử dụng trong bê tông. Và ông đã khảo sát rất nhiều các cái nhà máy điện ở Việt Nam. Thì tôi sẽ hỏi một cái câu hỏi là ông có lời khuyên gì về việc là xử lý các cái phế phẩm của nhà máy nhiệt điện để mà sử dụng trong bê tông theo kinh nghiệm của Nhật Bản. Okay. Dear Professor Dosho, I know that you are the professor in using the fly ash and the material from the power factory to use as the admixtures in concrete, right? And you have already make big investigations of many power plants in Vietnam. So do you have any suggestion for procedures of treating the materials of power plant in Vietnam in order to use them as the fly ash, for example, as admixtures in concrete? Thank you. Can you share?
Okay. Very good question. And same standard fly ash and blast furnace furnace is in Vietnam and Japan. Same standard. But recycled aggregate standard in Vietnam, same 2018, established recycled cost aggregate. But recycled aggregate, Vietnam's recycled aggregate is lower. Absolution, water absolution is under 5%. But under 5% is very difficult. This is a recycled aggregate class M, same. But it's M is this type machine, very high cost. But this is the Vietnam. In Vietnam, the forecast is same system. This is the same system. In Japan, tested. But the Vietnam plant is using this system. Okay. But this system is recycled aggregate class L. Class L is absorption, water absorption 5 to 7%. It's an easy system. In Vietnam, using this system. Okay.
Thank you, Professor. Các vị quý khách thì nếu mà có câu hỏi có thể chuyển qua ban thư ký là thầy Minh và thầy Tùng ở dưới để chuyển lên trên ạ, và hoặc có thể hỏi trực tiếp Bài giới thiệu của chúng ta còn nhiều câu hỏi thì các vị khách có thể gửi thêm. Sau đây thì để rút ngắn thời gian, các vị khách có thể gửi thêm câu hỏi và để sang cái bài thuyết trình tiếp theo ạ.